Good day, class. Today we will be discussing the last of the flexible power transmitting element, which is the wire ropes. So we will be discussing what are the application, the usage, and what is actually a wire rope. So wire ropes are usually uh, are strands uh, or mechanical cable that is made up of several strands, usually twisted into helix form. So these are used to design or designed to handle tensile loads, and are also used as application where you need strength, flexibility, and durability. Okay, so the basic the structural components of a wire ropes, basically you have the wire, you have the strands, you have the core. So the wire, this is the individual metal that make up the strands. And then the strands is the group of wires twisted together. And then the core, this is the central part, which is around the strands that are twisted. So the core can be either fiber core, which is made out of natural or synthetic fibers. You also have the independent wire rope core, and which is a small wire rope as the core, and then you have the wire strand core, which is the single strand core. Okay. The common usage of this are in cranes, hoist, elevators, mining, construction, cable cars, of course, for transportation, and bridges, rigging, and also the derricks, oil derricks. No? So the common type of wire ropes are 6 by 19. No? So 6 by 19 are commonly used. These are commonly used in general purposes, hoisting like that, cranes, drilling, elevators. Okay, so the characteristics of a good characteristic, of course, of the cable or the wire ropes are the braking strength. Of course, we need to lessen the braking, or it it the wire rope should not be break uh it should have a high, sorry, it should have a high braking strength. And also it should be fatigue resistance, because it will be always having fatigue, no? And also the elongation. So uh of all of these characteristics, braking strength is the key characteristic of a wire rope. So we need also, in designing a wire rope, you need to know whether what are the load requirements needed, what are the operational stress, and of course the environmental factors. Is it located in cold area, temperate climate, tropical, or whatsoever? So we need to have the right materials for that. No? Okay. So the maintenance for this uh, should have visual inspection, the wear indicators, and also the lubrication. So NDT methods, NDT means the non-destructive test. So usually you should, these are the crucial maintenance for the wire ropes. Of course, the NDT is before the installation. So regular maintenance is crucial. So like the visual inspection and also the lubrication. Okay. So I already told you that the some of the application of the wire ropes are in cranes, elevators, suspension bridges, and also the cable cars. Okay, so in the Philippines, we have the international. We are following the international standards. So ASTM is, of course, another one for material testing. So ASTM is the American Society for Testing and Materials. So we are always uh, following these standards. Okay. So the factor of safety for use used in designing wire ropes for elevators, which is the highest, you need to have at least 8 to 12 factor of safety. For mine hoist, you need 2.5 to 5. Cranes, motor driven, will be 4 to 6. Cranes and that is hand powered is should be 3 to 5, and derricks 3 to 5. Derricks are in oil and gas, no, because in oil and gas. So when you have this, in order for you to have this, so the right when you have this, the right uh reading of this is the first number should be the number of strands, and then the second number is the number of wires per strand, and this is the nominal diameter, and the PS, IPS, and MPS means flow steel. No, PS is flow steel, M is mild flow steel, and then IPS is improved flow steel. So these are the common usage of your wire ropes. Okay, so wait for a while. Okay, so like what I told you, these are the okay. So for the construction of individual wire should be twisted into wires. No? Wires first, and then the strand. And then another thing is that uh this is an example. This is wire. This is a strand. Strand is this. And then you have the core. The core. Then you have this. You have this. So these are your parts of your wire. So this is wire. Then this is your strand. And then this is your core. So just none. Okay. So we have the example just now is 7 by 8 PS, 1.5 inches diameter. So in order for you to write this is it is it is a wire with 7 strands, and then 8 and 8 wires per strand made out of PS is flow steel, uh, closed steel material having 1.5 inches, having nominal diameter, sorry, having nominal diameter of 1.5 inches. Okay. So another one I forgot to inform you regarding the wire construction. So the wire construction, you have the regular lay, and then you have the lang lay. Okay. So when you say regular lay, these are wires twisted in opposite direction. Direction. While the lang lay is wire strands that are twisted same direction. Okay. So in regular lay, you have the right regular lay and then the left regular lay. While lang lay is you have the right lang lay and then the left lang lay. Okay. So the common use is the right regular lay. Okay. So the materials is not only for plow steel, mild flow steel, improved flow steel. You can also have wrought iron. You have also cast steel. You also have alloy steel. You have also stainless steel, carbon, copper, and you also have the bronze. Okay, so we solved one problem. Okay, so then the problem is a a rope weighs 300 kilograms. Uh, uh, and acceleration is 9.81 meters per second. Find the total uh, tensile load when 1/2 inch 6 by 10 flow steel wire rope carrying a load of 5,000 kilograms, sorry, is bent around 1,200 millimeter diameter sheet. So from the materials that I've sent to you, in order for us to get the tensile load, we have our visualization first. You have this. So you have the tensile load here. Then you have the weight of the load. And then you also have the weight of the rope. And then you have the acceleration. Okay, so we have Ft. The formula is Ft is equals to the weight of the load plus weight of the rope plus 1 plus the acceleration over the gravitational acceleration. Okay, so what is the weight of the load? So you have a load of uh, You have 5,000, and then you have 300 kilogram. Then you have acceleration there, 9.81 over 9.8. Okay, so that would be what? 5,300 times 2. So you have tensile load of 5,300. So 10,600 kilograms. Okay, so next we have a 10-year life of wire rope is subjected to 1,000 bends per year. Calculate the number of bending for it to fail. Okay, so the formula for that is the life is equals to NB, which is the number of bearing or bendings to failure over the usage or bends per year. So you have the life. So we are looking for the number of bendings for it to fail. Okay, so we have the life, you have 10 years. And then, and this, the one. Then usage bends per year, you have 1,000 bends. So then you can have the NB. Okay, so that is for our wire ropes. So we have a short discussion about the wire ropes. And also, you can also check the PMC code or the Philippine Mechanical Load, which deals with the minimum. For example, you are designing an elevator, no? So if you have a given, or if there's a question or problem saying that is asking for the minimum rated load for a passenger elevator. So in order for you to determine the number of elevators, so there shall be one elevator uh, per 220 persons uh, occupying the building other than the first floor. So by floor area, you have 9.3 square meters of floor area. Is average density of occupancy per person. And then the floor area is divided by 9.3, which is equal to the number of person. And then that number of person is divided by 220, which is the number. Then you can get the number of elevators. Okay. Also have, I think if I'm not wrong, I also give you that formula. Okay. So you also have, if I'll just give you the formula for an elevator which is inside the platform area of not more than 4.65 square meters. So you can have wait, is equals to 35.1 a squared plus 326.224 area. The four area. Multiply by the area. Um W is the, of course, W is the maximum rated load, and then A is the area. So this is not more than 4.65 square meter. So if it's more than 4.65 square meters, you have W is equals to 2.458 A squared plus 611.36 A minus 621. So this is the formula that will be used for getting the maximum rated load. Okay, so that is for the wire ropes. Okay, thank you.